But we don't really want to know just what the snow grains look like now. We want to know what they looked like a week ago. We want to know what were they originally deposited as, how did they change over the course of the winter, but also how did they change in the last week or 24 hours. So if we were out here 24 hours ago, what would this look like? Or let's say 48 hours ago. How might this have been different? So if we think about the factors that are controlling, you know, what your snow distribution is like, what would they be? Let's say there's 3 factors. We just mentioned them. Wind, topography, how much it snows. Oh, there's another important one in there though. But also when the ice freezes. I mean, if it snows and the ice isn't frozen yet, if there's no ice, then you're not going to get any accumulation in that area.
Or, you know, I don't know if the melt, see there's these look a lot bigger, and then there's, he was saying there's that melt layer, right. And then the one at the top is pretty big.
Make sure your layers. You can make that top layer.
I mean, I can see 3, but yeah, there may be more than that.
You can share the microphone. Why do we want to know something about snow on sea ice?
Because it's going to affect how quickly things freeze or melt.
It's a medium between the ice and the atmosphere normally.
So all of the energy fluxes are going to be mediated by the snow.
So first we took a total depth and then went through with just either our hand, our finger, a pencil or a knife to see if we could get into the layers, and then we wrote down where those were. And then we took these tools and took a known size sample, measured the mass so that we know how much water is actually in the snow.
This is the way the density cutter works. Let's do that. Already teared it out. You got exactly 100 cc. So 0.39. And see, it says 38.6 or whatever, but all you have to do is move the decimal place over 2 and you get the grams per cubic centimeter. So it's nice. There's not really any conversion other than 2 orders of magnitude. You know that you're getting exactly that volume. And so I think it works a lot better to do density this way than using a core.
And then now we're kind of just looking at it under the microscope and playing with it a little more to see if we can tell what kind of snow it was before it got melted by the rain we had. I was just curious. And then we would go dig another pit elsewhere and do it again. Just see how it changes over a longer scale, how these layers vary.
2 major types of snow out here. What are they? Wind slab and depth hoar. What falls is 10 small crystals in the beginning of the year, gradually metamorphoses into one large crystal. And of course that's happening from the bottom of the snowpack up, so you get the development of this snow called depth hoar. But up in these systems, the depth hoar is important because it's a better insulator. If you have really fine grain wind slab, you know, grains that have been beat up and they're really, really small, they don't insulate very well. Whereas as you grow this depth hoar over the course of the winter, it insulates really well. It's been through many iterations, and to reach this final stage, it's a GPS magnet probe. so it takes snow depth and GPS recording, automated.
Okay, well, it's called the Magna probe because, well, you're probing for the depth of the snow, and the Magna part is because there's a magnet in here that detects the magnet in here at whichever depth it's at, and then it sends the signal back to the data logger to log the depth of the snow.
So here's the GPS Magna probe. This is developed by Matthew Sturm and John Holmgren. These are the two batteries right here. Plugs into the data logger, stores all the data. There's a little power button, the green light's on. That means that not only does the data logger have power, but the GPS and the keypad and the Magna probe also have power. You control the data logger with this keypad. It's user-friendly module here, and he's hanging on to the probe. We've seen the probe already, but that gives you an idea what the guts of the thing looks like. If you don't have snow at the surface, if it's windswept or you have very little snow, you oftentimes can't get melt ponds at the surface of the ice. And these melt ponds, of course, lower the albedo, right, and really speed up the melting. So that's just an example of the type of things to be thinking about, of how, you know, a deeper or shallower snowpack is going to affect the sea ice. And this is something that you guys should think about. It's something that I'm thinking about while I'm up here. You know, how the snow, it's not just mediating the flux of energy, but how else it is affecting the sea ice.